Hello, good afternoon. Welcome to series of lectures on microprocessors and microcontrollers subject. I am Seshagiri Rao, Associate Professor, the Department of Electronics and Communication Engineering. Today I am going to discuss about the addressing modes of 8086. So what is addressing mode? Addressing mode, it indicates the way of locating the data or operands. And depending upon the data type used in the instruction and the memory addressing modes, any instruction may belong to a particular addressing mode or it may belong to different addressing modes. It is not necessary that a particular instruction should belong to only one addressing mode. It may belong to one or two or three more addressing modes. So basically addressing mode, it indicates where to locate the data or the operand. You know, the instruction contains the opcode and the data. And the data is, it can be operand, it can be a register, or it can be a memory location. That means the data can be present in the register or a memory location, or it may be present in the instruction itself. So addressing mode, it indicates how to locate the data. And depending upon the data type used in the instruction, a particular instruction may belong to one or more addressing modes. And addressing modes describe the type of operands and the way they are accessed for executing the instruction. So these are the different addressing modes. We have immediate addressing mode, we have direct addressing mode, and register addressing mode, register indirect addressing mode, indexed addressing mode, register relative addressing mode, based indexed addressing mode, or relative based indexed addressing mode. So these are all the different addressing modes which are used by the instructions of 8086. Now first let us see the immediate addressing mode. In immediate addressing mode, the data is a part of the instruction. That is a special feature of this addressing mode. So here the data is a part of the instruction and it appears in the form of successive byte or bytes. For example, let us take this instruction move AX, 0005. So this instruction, it transfers the data 0005 into the register AX. So before execution, let us say the contents of AH and AL are FB and 6A. So before executing this instruction move AX 005, the contents of AX are 6A and FB. And after execution, AE means after execution of this instruction, the contents of AL become 05 and the contents of AH become 00. Suppose if you write move AH FF. See AH, this is the immediate data and this is the register. Okay. So this register, it is a 8-bit register. So you have to put only 8-bit immediate data in the instruction. So in this case, what happens? Before execution, let us say the contents of AH are 8A. And after execution of this instruction, the contents of AH is going to become FF. So this is the immediate addressing mode. So here FF is the immediate data. So the immediate data can be 8-bit or 16-bit in size. Okay. The next addressing mode is direct addressing mode. So in the direct addressing mode, where the operand is located, that address is specified very clearly in the instruction. So that is why this is called direct addressing mode. So in the direct addressing mode, the address of the operand is very clearly mentioned in the instruction. For example, if you take move AX 500H. So this address I am putting in brackets. If it is data, I don't put the brackets. Because it is the address, so the address is covered by two brackets. So move AX 500H. So here, let us say the contents of the memory location 500H is 46 and the next memory location is 6A. Okay. So the contents of the memory location 500H is moved to AL register and the contents of next memory location is moved to AH register. Okay. Now suppose if I write move BL 5210. So in this case what happens? This is only a byte transfer because the destination register BL is 8-bit register. So only one byte of data is transferred to BL register. So in this case what happens? So this is 5210 and this is 5211. So this is only offset address. I am talking about only the offset address. How we calculate the total physical address? You take the base address from the corresponding segment register and you add 0 to that, and to that you have to add this offset address. So now I am talking about only the offset address. So the contents of the memory location whose offset address is 5210 is transferred to BL register. So this is 88. So 88 is transferred to BL register. So this is BH and BL. So this 88 is transferred to BL register. So this we are not bothered because this is, so that's why I am putting X. Next addressing mode is register addressing mode. So in register addressing mode, the data which you have to operate on that is present in the register. In the earlier direct addressing mode, the data is present in the memory location and that address we are specifying very clearly as a part of the instruction. But in register addressing mode, the data is present in the register. So in the register addressing mode, the data is stored in the register and it is referred using the particular register. And you can use all the registers except IP. You can use all the registers. So that is the register addressing mode. For example, if you see move BX, AX. So what is here? AX is a source register and BX is a destination register. So the data transfer takes place from AX register to the BX register. So before execution, let us say the contents of AX is 1F20 and let us say the contents of BX is 4050. So when you execute this instruction, then what happens? 20 is transferred to BL and 1F is transferred to BH. So that's how it is going to happen. So 20 goes to BL and 1F goes to BH. And please understand here one thing, that the source and destination registers should be of the same size. So you can say move BL, AL, but you cannot say move BL, AX, because AX is 16-bit register and BL is 8-bit register. So this is not valid instruction. So both the source register and the destination register should be of the same size. So this is all about the register addressing mode. Now coming to the next addressing mode, register indirect addressing mode. So here the operand is not present in the register. The difference is the address of the operand, which is nothing but a memory location. So that address is specified is put in the register. So the processor sees the contents of the register, it notes the address, and it goes to the memory location to that address and it acts upon the operand. See, that is the register indirect addressing mode. So sometimes the address of the memory location which contains data or operands is determined in indirect way using the offset registers. So this mode of addressing is known as the indirect addressing mode. So in this addressing mode, the offset of the address of data is either in BX or SI or DI register. What is SI? Source index register. What is DI? Destination index register. So the default segment is either DS or ES. So data segment or extra segment. For example, if I say move AX comma BX, okay, then what happens? Let us say the data segment contents are 1A AC. 1A AC. Okay. And let us say the contents of BX are 2FC0. So here, how the effective address is calculated, the process, see there are two units in the 8086 microprocessor. If you see the function diagram, there are two units, bus interface unit and execution unit. So the bus interface unit, it calculates the effective address, taking this base address from the segment register and the offset address from the pointer registers. It calculates a physical address, 20-bit address. So here 1A AC, so 10 is automatically added to this one, so this becomes 1A AC0, and BX, let us say BX contains 2FC0. So 1A AC0 and to that 2FC0 is added, then you get 0. And what is C plus C? So 12 plus 12 is 24 and 16. So you get 8. So 8, 1. So here you get A, D, 1. So this is the 1DA80. So let us say this 1DA80 contains 23. So when you execute this instruction, move AX comma BX, the bus interface unit, it calculates the 20-bit physical address, and the 20-bit physical address is 1DA80, assuming that data segment is initialized with 1A AC and BX is initialized with 2FC0. So the contents of the memory location 1DA80 is transferred to AL, and the contents of next memory location 1DA81 is transferred to AH memory location, that is 2A. So this is how this register indirect addressing mode it works. Suppose if I say move AL comma BX. So in this case, what happens? Only one byte of data is transferred. So what is that one byte? 23. So 23 only is transferred to AX. So this is AH and AL. So this 23 is only transferred because I am putting move AL comma BX. So this is don't care, not valid. So you can transfer either 8-bit data or 16-bit data using 8086 microprocessor. But basically 8086 processor is a 16-bit processor, and to have the compatibility with the designs which were made using 8085 microprocessor, you can the facility is provided to act upon the 8-bit operands also. The next addressing mode is indexed addressing mode. So in this addressing mode, the offset of the operand is stored in one of the index registers. So what are the index registers? Source index and destination index. SI stands for source index and DI stands for destination index. So these are the two index registers. So, and if I say move AX comma SA, so the effective address is calculated taking the base address from the data segment, and to that the offset address is added and the effective physical address is calculated, and the contents of that memory location and next memory location they are transferred to AX. Now suppose let us say the contents of DS is 101A, and let us say the contents of SA is 2021. So what is going to effective physical address 101A, 10 is added to that 2021. So you get 1, what is A plus 2? B, C, 1, 2, 1. So the contents of this memory location 121C1 is transferred to AX AL register, and the next memory location 121C1, 121C2 is transferred to AH register. So the data is available at the offset address which is stored in SI or DS. SI in DS. So this is the indexed addressing mode. So here we use the indexed registers SI and DI. SI stands for source index and DI stands for destination index. And what are the default segment registers? DS and ES are the default segment registers for this addressing mode. The next addressing mode is register relative addressing mode. So this addressing mode, the data is available at an effective address which is formed by adding the 8-bit or 16-bit displacement to the contents of any one of the registers BX, BP, SI or DI in the default segment. What is the default segment? Default segment registers are DS or ES, data segment or extra segment registers. Now, for example, move AX 50H BX. So here, what happens? Let us say the contents of BX is 13C8. So this is the offset address, and the contents of data segment which contains the base address is 5FCA. Let us say. So what the bus interface unit does? It adds one 0H to segment registers. So 5FCA becomes 5FCA0, and to that 13C8 is added, and 50, because 50H is mentioned here, this 50 also is added. So then you get total as 5FCA0, 13C8, to that 50 is added. So you get here 8, and A plus 6 plus 5. So 6 plus 5 is 11, 11 plus 10 is 21. So 21 is, you get here A is 10, 10 plus 6, 21, 21, 6. So you get here 5. So you get here 5, 1. C plus, this is D. C is 12, 4, 16. So here you get 0, 1, and F plus 1. So you get here 2 and 6. So this is the one. Okay. So here 62058. This, okay, 6, and this is 62059. Okay. So this is 62058, and this is 62059. So the contents of these registers are transferred to AX register, as you see here. So A2 comes to, so A2 comes to AL register, and 3F comes to AH register. So here the relative displacement also is mentioned as a in the instruction. So there is a register relative addressing mode. Next we have based indexed addressing mode. So in based indexed addressing mode, the effective address of the data, it is formed by adding the contents of a base register to the contents of index register, and the default segment register may be extra segment or data segment register. So for example, move AX, BX, SI. Okay. So here how the effective address is calculated, you take the contents of SI, the source index register, you take the contents of BX, and to that you add one 0H to DS register. That is why I am putting multiplied by 10. Then the total physical address is calculated, and the data transfer is accordingly done. Suppose if you take the contents of DS is 131231, so 10 is added. Let us say the contents of BX is 1121, and let us say the contents of SI is 0011. So then, uh, so uh, so 123 10 11 21 and 0011. So you get here 2 4 4 3 1. So the contents of the register, the contents of the memory location 13442 is transferred to AL register, and next memory location, what is the next memory location? 13443. So that next memory location data is transferred to AH register. So this is the based indexed addressing mode. So here the effective address is calculated by adding the contents of a base register, which is BX or BP, to the contents of index register, which can be SI or DI, and data transfer is accordingly it is done. So there is a based indexed addressing mode. Next addressing mode is relative based indexed addressing mode. What is the difference between this and the earlier addressing mode? Here you can put the relative displacement also. So here you see this is the difference. 50H is the extra data. So this 50H is put extra, and accordingly data transfer is done. Suppose if you say the contents of AX is, the contents of data segment, let us say it is 1212. So 10 is added to that automatically, and let us say the contents of BX is 0122, and let us say the contents of SI is 1100, and because I have put 50H, so that is a relative displacement. So you have to put that relative displacement also. So you have to calculate the effective address, which is nothing but 2, 5 to 7 plus 2, 9, 3, 2 plus 1 is 3, 1. So the contents of this memory location one 3 3 9 2, and what is the next address? 1 3 3 9 3. So 22 34. So this data is transferred to AX register. AL and AH. So here you get 22, and here you get 34. So this is relative based indexed addressing mode. So we have discussed about various addressing modes. What are the and addressing modes? Basically, they indicate how to locate the data, and the different addressing modes are immediate addressing mode, direct addressing mode, register addressing mode, register indirect addressing mode, indexed addressing mode, register relative addressing mode, based indexed addressing mode, and relative based indexed addressing modes. So immediate addressing mode, the data is a part of the instruction. So you don't have to search anywhere for the data. In direct addressing mode, the address is very clearly specified in the instruction itself. In register addressing mode, data is present in the register, and in register and indirect addressing mode, the memory address is put in the register, and in indexed addressing mode, we use the registers SI and DI, and in register relative addressing mode, we put the displacement value also, like 50H or 60H, so and so. And in based indexed addressing mode, we use the index registers SI or DI, and in relative based indexed addressing mode, in addition, we use the displacement value and so on. So with this, I conclude today's session on the addressing modes of 1886. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.